For thousands of years, humans have used traditional mining techniques involving sinking tunnels or large pits to recover relatively small amounts of useful materials, like gold and copper. What remains is usually, at best, a scar on the landscape, large amounts of waste material and habitat destruction. At worst, the practices have led to environmental catastrophes. Now, an international team, including researchers from the University of Western Australia, have found a way to harness the power of electricity to achieve the same mineral recovery, but without the environmental costs. By placing electrodes into rocks containing precious metals, the researchers use an electric current to push through chemicals that dissolve and extract the metals locked up inside. This allows the metals to be retrieved with minimal disturbance to the ground surface. I'm Charlotte Berkmanis, and I spoke to Henning Promer about his work.
We did discover that we could use electric fields to transport, to extract copper, but also other metals from ore bodies. And we have found in the laboratory that we can transport copper over several centimeters just by applying a direct electric current. So we have then taken computer simulations to reproduce these experimental results, and we have then constructed a computer model of the real mine site and have then found through our simulations that the whole concept could work to really extract copper from an ore body.
What's the difference between your new method and how the mining industry currently extracts copper?
It's very, very different. Since the Bronze Age, essentially mining means that you have to dig up the ground and you have to process huge amounts of overburden material just to get to a tiny fraction, for example, of copper or gold. And you have then to extract the copper or gold from that huge amount of material. And then you're left with a lot of waste material. And in what we do, it is very different, that we do something that's much more like a keyhole surgery, that we drill down to where the copper or gold is actually sitting deeper in the earth. And then we don't need to really dig up all that material that ends up being waste.
Would you say that this is a game changer for the mining industry?
Yeah, over long term, it will be changing the way mining could work dramatically. Of course, we have to be careful. At the moment, we are working at a very small scale, and it still will require quite an effort to make the technology really efficient at the field scale or for a real mine. But at this stage, we haven't seen any real showstoppers. And so that's why we're quite excited. And we just want to now go from the laboratory into the field within the next 1 to 2 years and then see if it's working there as well.
So looking at the effects of the environment, you did highlight that it could reduce waste, but is it possible to use renewable energy with this technique as well?
Well, absolutely. That's the whole idea, that we would cover all our energy needs through renewable energy. So we would imagine mining countries like Australia or Chile that you could have solar energy, but also maybe wind energy to complement it. And one of the disadvantages of the renewable energies generally is that the energy is only supplied in an intermittent way. But for our technology, that doesn't matter, because at the end, it just really, the amount of copper, for example, that we can extract is just proportional to the power that we apply or to the energy that we apply. And whether we apply it intermittently or in a very constant way, that doesn't really matter much. And there's indeed indications that some kind of pulsing current might even be helpful.
Do you think this would impact society as a whole as well, or just the mining industry?
I guess for us, it's still a long way to go, but we're very, very excited to be on that journey, because we feel like it is a concept that can really change the way mining works. And so that's just part of change of how our whole society is going to operate in the change that we're going to see over the next few decades.
Henning Promer there, and that work has been published in Scientific Advances.